everybody. My name is Bernhard, and I'm very happy to be here and to be able to present you today two very exciting stories. One is about sleep, and one is about an extremophile bacteria. I'm coming from Mibelle Biochemistry. We are placed in Switzerland and around 60 people working for active ingredients for skincare. Let's start with the topic of sleep. I hope you had a good sleep tonight. In our modern society, this is not normal anymore. Many people do not achieve the recommended level of 7 to 9 hours of sleep per night. It's not about just the hours, it's also about the quality, and stress and poor sleep hygiene is reducing the quality of sleep as well. So we got not long enough sleep, but also bad quality of sleep. This leads to tired appearance of the face and of your skin. Young individuals can recover very quickly from this, but if you're not young anymore and you do this over a prolonged time because you're under stress all the time, this acts like a general aging factor, and it's comparable to high UV radiation or oxidative stress, which leads to a long-term negative effect on the skin, including wrinkles and so on. Now, it's probably the #1 underrated public health issue. So the awareness is increasing, but it's still not known how deep the impact of not enough and not good enough sleep is. And there's a need from the brands to develop evening facial skincare to tackle the stress and to make sleeping easier and better. This is not so easy. It might work with the help of rituals, but there is a need from the consumer side. Because, for example, in the US, the millennials are getting more and more aware of the fact already more than 50% are focusing on their sleep quality. In the UK, almost 40% of the people say enough sleep is hard to get during the working week. There was a report of the US that almost 80% of the US will not get enough sleep during the week. And this is a very bad situation we have to tackle. All in all, we can say the continuous lack of sleep does not only have a negative effect on your general health, but also on your skin and on your physical appearance in general. It happens to me that sometimes in the morning I look into the mirror and say, "Hello, old man, how are you?" This is more and more getting to a normal state. There are also quite some statistics about this. For example, in the United States is a statistic that during the last 80 years, the average sleep per person has been reduced massively. And there's another statistics, excuse me that this is in German, but it was a questionnaire on the quality of the sleep, if the people get enough sleep in general. And in the blue line, the people answered this question with yes. And in the dark blue, the answer was not really. And in the gray scale, the answer was definitely no. And down here below, you see countries from Asia where the stress rate is very high. And this leads to severe problems. Now, the question might be, what is the reaction of sleep deprivation in our body? And there has been quite some research about this, and one found out that this sleep deprivation has a deep impact on protein folding. You see here a model of a cell with the cell organelles, You've got the endoplasmatic reticulum. This is a cell organelle that is responsible for the production of proteins, including correct folding of the protein and cell detoxification. We also see here the mitochondrion, that is like the energy source of our cells, where the energy is produced. Now, what is protein folding? In protein production, everything is started by activating a certain gene which encodes for the amino acid chain. But then you only got the chain of amino acids, you've got an unfolded long protein, and the function of the protein is very dependent on the three-dimensional structure. And therefore, the protein has to be folded in the correct structure to get active. And an active protein has then this three-dimensional structure and is working. If it's not in this structure, the protein will not function at all, independent if this is an enzymatic function or if this is a structural function. For this process to fold the protein in the correct form, there are chaperones. These are helper proteins that assist the folding process. This folding process is needing a lot of energy, and the energy is coming from ATP. That's the fuel of the cell, as we might know, and these chaperones are using them up. Just for your understanding, an active protein looking like this might be in a raw egg. If you boil the egg, you are going into this direction. So denaturated proteins are unfolded or wrongly folded proteins. Now, why is this so important? In aged and in chronic sleep-deprived cells, the chaperone production is reduced, as in general, the protein production is reduced. If you don't have enough chaperones, they cannot fold the proteins properly, so this is impaired, and you get misfolded proteins. They can accumulate, and this will cause a stress to your endoplasmatic reticulum, and this leads to cell damage, and it's a very vicious cycle. So insufficient recovery of the cells during sleep will harm your regeneration and repair of the skin. You will get a dull skin. So the cycle is really a vicious cycle. So you don't get enough or not good enough sleep. It's both that matters. So your protein production is impaired. This leads to reduced chaperone production, and the chaperones are not able to fold the proteins correctly, and this leads to an ER stress, to cell damage, and this to aging. And all these effects together leads to a less effective cell recovery system, and this ends again then in a reduction of protein production. So it's once in the cycle, it's a really hard way to get out. I want now to completely change the topic to a more positive side. It's about expedition we did with Mibelle Biochemistry. It's almost 7 years ago. We tried to discover new extremophile microorganism for the use in cosmetics. So this this expedition was taking place in close to Zermatt, and Zermatt is the village that is very close to the Matterhorn. You might know this famous mountain, and there we took samples. So we tried to took samples from glaciers. Due to the environmental conditions nowadays, the glaciers are shrinking. And so there are microbes that were hidden maybe for hundreds of years. They become accessible, and they might harbor very interesting possibilities, abilities, ingredients, and so on. We work together with a professor from Chile, Jenny Blamey, who you can see on the picture on the right side, because she was a specialist for isolating extremophiles from regions like the South Pole, and Chile itself also harbors a lot of extremophile microorganisms. And she helped us to do this in a professional way, because it's very difficult to isolate the bacteria. On the one hand, not to destroy the cells during sampling. On the other hand, not to contaminate the sample spot where you take your samples by yourself with your equipment, and so on. In the next step, we analyzed their samples on microbial content, and we could isolate over 80 different microbial strains. So imagine on a glacier where you do not expect life to be at all, there are a lot of microbial communities living and prospering. Now, consider that most of researchers familiar to this field agree that probably 99% of the microbial community cannot be isolated because we cannot grow them. This is what all the knowledge is showing. Translated, this means these 80 different microbial strains we isolated represents only less than 1% of the total population. So for me, this is very impressive how diverse the microbial cultures on even places like glaciers are. We did several genome sequencing and found one very interesting strain. It's called the Iodobacter subspecies, which is a psychotolerant bacterium. And we further cultivated this bacterium in a bioreactor to obtain biomass. The Iodobacter can produce violet pigments and exopolysaccharides. The Greek word ioides means violet color. That's where the name is coming from. That's why it's called Iodobacter. Iodobacter is, as I said, psychotolerant. This means he is able to grow on very low temperatures, close to freezing temperatures, and he has no problem at all with freezing and thawing cycles. We decided to cultivate it in a non-violet form, so leaving away the pigment formation, because the pigment is not a very stable pigment. This is not good for cosmetic active ingredients. And we also found out that the activity is independent of the pigment itself. We do a spray granulation of the Iodobacter extract and maltodextrin to get, in the end, a preservative-free product. A few more words about the cultivation. It's very difficult, actually, to find out the right parameters to cultivate bacteria that you don't know yet at all. So you have to find out about all the parameters the bacteria needs to grow, starting from the temperature, from the favored pH, from the favored carbon source, to maybe some essential amino acids they need, and so on. This is a long work of development. There were included even 2 bachelor theses, but we succeeded and can now grow this Iodo under a fully controlled environment. This is completely reproducible, and we are using defined media, meaning we are not working with complex media like yeast extract and so on. As I said, we do a spray granulation, and for the inky, we use the name succinic acid. This is part of the extract. We find this substance in the extract, and this is a China OK inky we are using, and we recommend the use level of 1 to 2%. Now, the question might come up, what does this have now to do with sleep? There's this topic with chaperones I already mentioned. There are several different chaperones. One of them is called BIP, or binding immunoglobulin protein, and this is one of the major chaperones in the endoplasmatic reticulum. And there's literature that this BIP is specifically affected by sleep deprivation. It's also researched that the BIP is upregulated before the increased production of collagen at night during the cellular regeneration process. So this BIP is really a key player when it's about the production and the correct folding of the collagen. I also already mentioned that the chaperones need ATP, as this is the energy currency of the cell, and without ATP they cannot work properly. Now, ATP is produced by the mitochondria, and the problem is the mitochondria is also affected by a stress by the endoplasmatic reticulum, because also proteins for the mitochondria are not folded properly, and then the ATP concentration drops because of the stress in the ER. And for example, there is evidence that for only 3 hours of sleep deprivation, there is a significant reduction in ATP concentration in the frontal cortex and lateral hypothalamus in the brain. So this is measurable, and this is very strong evidence for the connection of these molecules. Now we want to show how we can influence these effects with the Iodo extract. We used aged fibroblasts in vitro testing. They are grown for several passages to mimic the aging process, and we used 1% of the Iodo extract and incubated the cells for 24 hours. And we looked at the expression of 4 different chaperones coming from the endoplasmatic reticulum. And we saw that the genes were highly upregulated, especially for this BIP I already explained you, but also for the 3 others we looked at. So there's this endoplasmin that has a critical role in protein folding, and there are 2 more, the calnexin and the calreticulin. They are important for the protein quality control. So they prevent the release of misfolded proteins from the ER. So this indicates that isowake, that's how we call the Iodo extract as a product, could promote protein folding to carried out more efficiently despite aging. We also looked at the ATP production, and therefore we worked with a very interesting test system. So we mimicked the endoplasmatic reticulum stress in the cells to induce this sleep deprivation system, to have a test system where we can mimic all these effects. And we wanted to investigate whether the isowake is able to reactivate this ATP production in these sleep deprived cells. And for ATP production, you don't need to wait for very long because ATP is produced all the time and very fast up and down regulated. And we could see there was a significant increase already after 2 hours if Eurobacter species extract is applied to the culture. Now, we also wanted to see whether we can reduce the ER stress of these special cells that are already sleep deprived. And there we wanted to look at the mitochondrial associated membrane. These are like contact points between the mitochondria and the membrane of the endoplasmatic reticulum. And if there is no contact or not good contact, you can color this. And you can see here that with the control, or you can see the pictures here, it's maybe easier. The healthy cells were not able to be colored, where the control has a very good colored membrane. And with the Eurobacter extract, you get even better results than the controlled healthy ones. So here you see in the results, it's significant reduction of this MIM contact points, and Eurobacter species extract decrease the ER stress in sleep-deprived cells very clearly. Now, in vitro tests are nice, but we wanted to show it also in vivo. There we did 2 studies. One of them was with Asian volunteers. As in Korea, the life is especially hectic, and we chose volunteers who were overworked and or had little and bad quality of sleep. And we applied our IsoWake in a cream together with a placebo, so one phase to the other phase for 14 days. And we looked at the wrinkle death of the crow's feet and the skin radiance, what was graded based on photographs. And here we got very good results, as we got a reduction of the wrinkles of more than 11%, where we had even an increase with the placebo cream. And for the radiance, we also got a significant increase of 9%. These were very nice results, but we wanted to compare this as well to a group of Caucasian volunteers, where we did the same study with the same product cream and placebo cream. And we again looked at the wrinkle death and the appearance, but we also did a questionnaire. Now, the appearance was significantly better. So the tiredness was reduced by 70%. And for the wrinkle deaths, we even got better results than in the Asian group. And it's very comparable, underlining the other results as well. You can see here some sample pictures. It's very obvious that you can see strong reductions of the wrinkles here, and you almost don't see this big crow's feet over here as well. In the questionnaire, 95% of the volunteers agreed to the point that they said the product helps my skin to look healthy. The product makes my skin feel soft and smooth, and the regular use of the product has had an overall benefit on my skin. 90% agreed to the statement that the product provides a healthy radiance. The product instantly provides me a skin that looks both healthy and beautiful. And very important, according to sleep, the product helps to make my skin feel fit for the day, like I had a good night of sleep. What can this product be used for? It will energize tired skin. It reduces wrinkles after only 2 weeks. It increases the radiance despite a hectic lifestyle. Applications might be energizing serums for fatigued skin, concentrates for glowing, radiance-enhancing face masks, or anti-aging treatments. I think the marketing benefits are based on a unique extremophile bacterium found under a Swiss glacier. This is a very nice story. It's completely sustainable as we can grow the raw material independent of the season and with a very limited amount of resources. It's a novel aging mechanism based on the protein folding and this chaperone activity, and the product is even without preservatives. And with this, I come to an end, and I thank you very much for your attention, and I hope you enjoyed the presentation. And I'm ready for questions now. Thank you very much.